How do we balance the need for large-scale and small-scale storage? There seems to be a key issue there about who does that. So I'd be interested in the panel's view on how we might approach that particular question. Go in the same order.
Do you want to start from that end?
We'll start from
Dominating
that,
the conversation.
Yeah, I mean, the complexity of the price signal from two essentially different markets, both the network market and the wholesale market, is obviously something that Ofgem is aware of and is trying to explore. We're not oblivious to this. It is obvious from the modelling done by a range of people, Gore and Sabat being one of them, that there is locational benefit and there is benefit from different markets. Ofgem is aware of this. The question is, what we're beginning to explore is how do we allow how do we get the correct price signals from both markets so that there isn't competing or there isn't contradictory messages being sent, that the market can actually work efficiently. Obviously this is being picked up as part of the Smarter Grids Forum issue and sort of indirectly as part of the Low Carbon Network funding experience, and obviously it's being picked up at a wholesale level by the Future Trading Arrangements Forum, which is looking at the complexity of how do we change the market arrangements in order to facilitate a range of technologies at lowest cost. It's not something that Ofgem is oblivious to. We haven't got an easy answer yet, but hopefully we can work with you in the industry. What is ultimately a very complicated issue, because historically the DNO doesn't have a market, it's not a market player. It's been a relatively passive provider of essentially network infrastructure. As part, obviously going forward, their role becomes a lot more active, and they will be, regulations permitting, be more active in managing their demand and their generation embedded in their system. How that interacts with the wholesale market is obviously something that we need to understand. We haven't really had that issue before, but it's something that we do need to work out and think about whether the current arrangements are actually fit for purpose. And there are a range of Ofgem forums looking at these issues, but as yet, no answer.
I think from my point of view is there again, the balance of need for large and small scale is there's a lot of unknowns. Ultimately, our networks at the moment aren't fundamentally broken. They work very well. They've worked the same way for a long period of time. The requirement for us to have smarter solutions, including energy storage, is the uncertainty that comes with the uptake of low carbon technologies. And as we've already seen, that actually government policy and changes and incentives can skew the market, as we've seen with generation, and you can get sudden surges, as we've seen with solar PV, from the domestic up to the primary network sort of connections. And ultimately, if the same thing happens with electric vehicles or heat pumps with other types of technologies, that could then drive our requirement for what type of storage we're going to need. And whether that is at the LV level in people's homes or whether it's at the network level, it very much depends on the solutions that come forwards and the impact that will have on the network, and then ultimately the solution that we need to find.
When Dave and I set out, we didn't want to build pump storage. What we really wanted to do was save the planet and do something through the markets that could reduce carbon emissions. Why did we end up doing pump storage as opposed to, that's a great idea, isn't it, putting a battery up in every house where you can get DC power out? I can answer that question really easily, that there was a defined market for pump storage. You could sell the output of what you have got. Now, everything I hear, we're completely technology neutral. What we want to be is a developer that understands how you make money out of storage. And we want to sell that to anybody who will buy it off of us. We don't want to sell technology. We want to sell the knowledge and the services that we have. Now, if I come back down to small scale, if you look there, it's really confused to me. First of all, and I spent a lot of time reading it, I still do not really understand where the money is going to come from the DNOs. I'm not sure if I develop a technology who's going to pay me. I can see it benefits the DNO, but how are they going to pay for it? If I look at some of the comments I hear, I think they're missing something because they're still in the field of dreams. You know, in the field of dreams, the movie, the great expression, build it and they will come, that is the biggest fallacy in business. You know, nobody is going to build anything unless they know people are going to come. So at the moment, all the money that is being pumped in to technology projects and tests is great, but nobody's going to build that or roll it out on scale till they know how they can make money out of it. And the problem of it, it's a network issue. You can't do it a little bit at a time. You know, somebody's got to make a big bet pretty soon about how it's going to happen. So I think on the big scale storage, the market is pretty defined. I think on small scale storage, it's amazingly confused.
Thanks. And I think part of what's come out is that we don't really know where the balance is between large scale and small scale at the moment. And that's thinking about the longer term and how the system will develop as we have more intermittent renewables come on the system. So there needs to be a greater understanding of how the system will operate over that sort of period, and seeing where the value is and how you can achieve a more efficient energy system is what makes policymakers and regulators think, well, you know, we want to capture that value and introduce mechanisms or incentives that will deliver that back to commercial organisations so that you can bring that through. I think a critical piece that we need to go through now is from Goran Strabak's work, looking at the value of storage. We need to dig a bit deeper and understand the sort of how different technologies play into that with their different characteristics and at different scales. It was a fairly broad piece of work. On the small scale, it didn't go down to the very small scale. So I think there's still a lot of work that we need to do that can help inform the future mechanisms.
If I can characterise Goran Strabak's Imperial College work, it basically said big storage near big wind, small storage near fluctuating demand. So I don't see any value in trying to work out what the balance is, because as everybody on this panel agrees, we don't know what the exact need will be and where it will lie on the system. What we do know is that probably the distribution networks are best qualified to understand the need at a local level. And at a national level, then I think it's a much more easier thing for people to get their hands on. So if we have lots and lots of big wind, you get much more benefit from having large-scale storage relatively proximate to that. If we have lots and lots of solar on house roofs and we have lots and lots of electric vehicles, then the value proposition for small storage is compelling. So for me, it comes back to make sure the market landscape, which is what Peter's saying, make sure the market landscape is there to allow people to react to the natural signals that are physically going to emerge as technology rolls out.
Phil Lawton from National Grid. I think the small scale question for me, what we haven't decided yet is what we want our distribution networks to do. Are we going to be supplying everybody by a heat pump? Is everybody going to drive an electric vehicle? And until we know where we're targeting, we can't know what network we need. And until we know what network we need, we can't know the best way of achieving it. If we need a little bit more, it may be storage. If it needs to be vastly more, then we might as well just get on and dig the roads up and put in big cables. And I think we need to know where we're headed for before we can actually try and finesse the journey.
Pick up that one. I think Ofgem's sort of view on this is fairly clear, is at the moment we're not sure whether electric vehicles or hydrogen will be the big thing. And the same with heat pumps, we don't know. And a crystal ball would be fantastic, because it would tell you exactly what you want to do. And the aim of all the innovation that we're looking at and researching is how can we push the existing network, squeeze as much out of the existing network as possible before then replacing, because then at that point we should know what the future outlook is going to be. we'll have a much better idea as to what we should replace it with and understand, should it be twice as big, should it be 3 times as big, or actually is it suitable as it is? So ultimately, the innovation is to buy us time in order to we have a better idea and better understanding so we don't have stranded assets. And that's the clear remit for why we've had the LCNF, is to demonstrate these technologies and to understand them so we can incorporate them and use them as an alternative to conventional network reinforcement where they're most appropriate. And there again, Rio is the same. It's to encourage us to do the right thing in the right places at the right time.
It's Chris Goodall here. Could I ask a question about the target that's been spoken about several times today, the 2 gigawatt target? I'm unclear what that means in terms of gigawatt hours. Is there a stated figure for that goes with it?
We just decided that 2,000 megawatts was more than enough for people outside the industry to get hold of. And to try and put a megawatt hour bracket on that would be not necessarily helpful. And I think we probably anticipated much of a discussion today talking about the 2 different types, both short-term and long-term. So it encompasses the whole range of it.
Can I guess that the implicit figure there is something like 5 gigawatt hours, or something like 1/200th of the daily peak demand in January of the UK electricity network? My question is, why could we possibly conceive of that being a sufficient amount of storage to deal with a high renewables future? In 20 years' time, we might have 6 times as much wind on the network as we have today. I'm not saying we will, but we might. That's the kind of number that's talked about in government documents. Over the course of the last 8 weeks, that would have meant that the UK would have been in an electricity surplus for most of the time, because we've been running, this has been a very unusual period, but we've been running at 5 or 6 gigawatts in electricity of wind production on today. With the nuclear, that would mean that most of the time over the last 2 months, we had a huge surplus of electricity. The kind of storage that's being talked about today is nothing like enough to deal with large-scale cyclones coming across the UK. Interconnectors won't help because those cyclones tend, on balance, to occur across Europe at pretty much the same time. We've got, at the same time, Germany continuing to invest heavily and pushing down wholesale prices to mean that interconnection is going to be virtually valueless for the UK. Now, my question is, how are we going to get in the UK a system that provides hundreds of terawatt hours of storage without using what the Germans are looking at, which is power to methane and power to butanol?
Anybody want to answer that?
I guess we're fellow travellers. My take on that, why are we developing small-scale pumped hydro? It isn't small scale, it's 600 megawatt hours, but in terms of what you're talking about, it's a lot. First of all, sites of that size, you're predominantly, I think, into a technology which is based on water or water storage, whether that be pumped hydro or whether it be, putting balloons under the sea or something on a massive scale. Currently, if you look at pumped hydro in the UK, trying to get sites of that capacity through planning, if they exist, is nigh on impossible. It's a brave person who's going to take it on. Secondly, raising the capital with the current revenue stream makes it nigh on impossible. So that would be my answer. I don't see how you're going to do it unless the market signals. And I'm not asking for government subsidies. I'm saying there's got to be some pricing mechanism that allows projects of that scale to be done, if that is what the national strategy of this country is for power generation and distribution.
I think your question hits at the point of scale which I was trying to make earlier. If we are committed to decarbonisation and we are committed to the technologies which allow us to deliver that, we are committed to this huge capacity need in certain situations. And it is not going to be just met by interconnection. It is not just going to be met by demand side. It is not just going to be met by storage. It is not going to be just met by flexible generation. You need all four. This is my fundamental point. We are talking about a very big scale issue if we continue with our commitment to decarbonisation. And at some point you have to commit to making sure all four levers of flexibility will be sufficiently scaled and in an economic way when we get there. Otherwise, you might have to think about, is it realistic? And maybe that's what the Treasury are thinking as we speak.
You've been waiting an awful long time.
Oliver Thorold, Quarry Battery Company. Unless First Hydro have plans to retire De Norwich and Festiniog, or unless they're not profitable, why are they to be further rewarded with capacity payments?
I will say Ollie is one of our investors.
So this should really be DEC answering it, not me, but I'll answer on their behalf. So basically, the capacity payments are therefore capacity. And, you know, if anyone has capacity, then there is an open market for that. And in order to prove we have capacity, you know, we can effectively provide generation, which we can over the peak, that avoids you having to build additional coal, additional gas units, because I think, as I showed this morning, you know, we had 1,000 megawatts on that ran over the winter peak that reduced the capacity that was needed from gas units or for coal units for that particular day. So we provided a vast amount of capacity, which is the equivalent to, you know, 1,000 megawatts of coal station. So that's why. And the capacity market is actually an auction. So there will be, not everyone that participates will get it. And effectively, you need to put yourself a price in there, and it's a cleared price going down. So actually, you know, First Hydro may not get a capacity contract if it bids too high and it needs too large a reward. So the capacity market is about getting enough capacity on the GB system, not who's getting it. And it's no certainty that any individual player, whether they're coal, gas, carbon, will get it at all.
Any other points? Yes, please.
So as someone who works mainly not in this country, maybe you can tell from my voice a bit, I'm from California and I work on international energy storage questions. And what I'm hearing here is what I hear in many other of my workplaces. I saw the last question, I thought I'd jump on it. What can we learn from other countries? What I hear again and again to Mike's slide is there's a lot of benefits and storage can do a lot, but storage can't get paid for it. And so in most of the markets that we've seen be very successful in deploying storage in the short term, they've said, who can get paid now? And then they go for that. They then share, as we've heard multiple times today, share that information in order to increase their own market. It's completely self-serving. And then you take that to the next step and say, okay, how can we get paid in more places? And while you're getting paid for the things you can get paid for today, you work on the things that are in your way to getting paid on the next step. And so I just feel like this is summing up a lot of, you know, smart people in this room have been saying this, but that's what we see in other countries as being the most successful. So if you're going to advocate for solar here, I mean solar, storage, I work on a lot of things, but I'm looking at the solar person right here. If you're going to say that we want a lot of storage out there, you know, perhaps it's more about articulating where people can make money on it now. This is what it seems like y'all did with Quarry. You said, here's an opportunity to make money. That speaks. So where are the rest of the opportunities? And then simultaneously working to create a bigger market for yourself. So, comment. I don't know if anyone disagrees with me. Please say it and articulate it strongly, and I'll love to talk to you about it.
Well, I thank you for volunteering that, because I was kind of avoiding the last question because I wasn't sure if we had much in the way of international experience here, but that's very valuable. But I mean, does anyone else have a view on what we can learn from other countries?
Absolutely. Lovely to hear California speaking out, because this is the leading edge of the energy storage industry, and we should take a leaf out of your book. because everybody we talk to, there's always seen a need for storage. It's recognized. DEC's taken a great step forward to boost the technology, which was the big question up to now. Now, there are some technologies out there, plenty of them, that can do the job. What we need is a market incentive, a simple one. And it happened with ROCs and FITs. Why can't we do it with storage? And I tend to oversimplify the whole thing, but at the beginning of an incentive scheme, it has to be simple. It gets more and more complicated as you get down the road. But I just don't think it's beyond the wit of Whitehall to come up with a very simple starting point, whether it's a per kilowatt hour incentive, as in Germany, whether it's a per kilowatt incentive as it is in California. They're simple, and it gets the ball rolling, and that's what we need. I think what Anthony Price was saying at ESN is we really need to push for a single person within Ofgem DEC, the whole Whitehall machine, that can be responsible for storage and just get the show on the road. It shouldn't be this complicated. We're wallowing around with all the little detail, which we have to do, I know, but someone's got to go right to the top and say, right, here's a simple way to get the ball rolling, and then it gets more complicated later on. The ERM, the reform mechanism, has just not been able to address it because it's so complex. And that's not because storage is new and it's coming at it from all kinds of different directions. And it just got bogged down in the new legislation. Anyway, I'm sorry, I'm rambling on, but that's what we need, something simple like California has done so effectively. Thank you.
Thank you. Any other views on international experience before we stop? Yeah.
I had just comment because the California stuff just de-risks the politics. You know, it's clear you can make a business plan on that. It's ambiguous here in the short term. And you know, earlier when they had SGIP, their FIT, that sort of started off rewarding PV, then it moved to fuel cells and other forms of storage. And so it was a very simple mechanism that just moved away. And that's why fuel cell companies like Bloom exist there, whereas Ceres and CNR don't exist here, because there was a payment structure to reward that industry. That was simple, de-risking the politics. So any storage company here needs to move there to get de-risked, or if there is a market here, we could stay here and deliver. I had one comment earlier about the small scale, which was, whilst Moix and Maslow focused on sort of that kind of scale, it's very interesting to look at the trajectory about how much storage is in homes and property anyway. So of all the batteries made in the world today, only a very small slice currently goes into grid-scale storage, and a smaller slice than expected into electric vehicles. The rest of the storage goes into product, in e-bike to laptop. And the most interesting thing with the growth in Internet of Things is the amount of energy customers paid for and storage customers paid for available and connected through smart. And so, you know, Google knows every single laptop which is on in the country today and where they are by IP address. And if Microsoft sends an update of Windows to switch off every laptop, it will switch off probably 0.5 gigawatt of demand just by Microsoft pressing a button saying, we think everyone should update their computer now. Bang. And so in the future, you know, I can do that myself, or anyone can do that. And so the growth of the DC demand space, you know, the iPod space, things moving at the speed of customer purchase, not the speed of DNO, and government EMR mechanism, are probably going to have a much more significant amount of impact and inventory available by 2020 at the pressure of a button, the de Norwigs distributed across people's homes. And we just haven't seen any mathematics analysis showing how significant that could be, except we're going to add 10 times more the number of devices into the grid at the small scale. So you talked about small versus big, but actually the very small long tail effect of the sum of the consistent on-peak demand of everything we use every day is growing reasonably astronomically, and is also connected by definition and available to demand-side mechanisms. And it's something I think will actually change all the rules here this decade. I think the EMR will change the rules for 2030 and be the right mechanism for that. But you know, so it's just a conjecture we have at Moixa.
Very interesting. I'm going to stop it there because we have a fixed length of tea break. Will you join me in thanking the panel for the